Hello and welcome to our first video lesson for Chapter 14 on sequences and series. Our objectives for today are to determine whether a sequence is arithmetic, geometric, or neither. And by neither, they could be quadratic, sinusoidal, something like that. But we're focused on arithmetic and geometric. We want to also write explicit and recursive equations to represent sequences. And then finally to use your equation to find a specific term in the sequence. Let's say that you have money in a piggy bank and you want to save some for a special purpose. You get a job that pays you $13 each day. This table gives the amount in your bank at the end of each day. And in day one, you have $53. So that's your starting deposit. And after that, it looks like you are putting away some money. In fact, if we do the math, 66 minus 53 is 13. 79 minus 66 is 13. So there is a constant there. Is this sequence arithmetic or geometric? And when we think about arithmetic, you want to think constant or common difference. So we're continually adding or subtracting the exact same value. If it's geometric, you're multiplying by that value. We call that one a common ratio. In this problem, we would say it's arithmetic because a constant is added each time, $13. So this common difference, the difference between consecutive terms is called the common difference. What is the common difference in this example? $13. We want to find the amount of money in the bank at the end of the 10th day. And we're starting with $53. We're increasing by 13 each day. If we do 53 plus 13 times 10 minus 1, we'll have $170. Now, since we started at T sub 1, the first term has no changes, and we make 9 changes to the first term. So that first term is the first place in our sequence, and then after that we do 9 changes. Find the amount of money in the bank at the end of the 100th day. Now clearly this one we definitely want to use an equation rather than try to just list out values. T sub 100 will equal $53, our starting value, plus 99 changes, or 100 minus 1. So 13 times 100 minus 1, total of 1340. And now we want to write an equation in general for T sub n, any day, the amount of money in the bank on the nth day. And this first formula, the name for that is called recursive. And it looks like this. We take our first term, 53. We take any term in the future, T sub n, and we set it equal to the previous term, T sub n minus 1. And we just do the common difference, plus 13. And we have to start at n equal or greater to 2 because if we start with 1, this value here becomes T sub 0, and that value doesn't exist with the way we define this. So we want to have a constraint that says n is greater than or equal to 2. That's not a big deal, but it's kind of formal in how we say the recursive routine. This other formula, called explicit, would look like 53 plus 13 times how many changes. And that's, like I said earlier, what turns into our equation like y equals mx plus. And again, the constraint that n has to be greater than or equal to 2. Sometimes these equations are set up with T sub 0 or U on your calculators. You'll see a U. We've considered 2 forms of equations called recursive and explicit to display a specific relationship, in this case arithmetic. We'll now consider both forms, the recursive and explicit, to display another relationship called geometric. This comes from a constant multiplier. A baby's parents buy a $1,000 savings bond on the baby's first birthday and receive an interest payment of 6% paid annually. Find the value of the bond as the child grows. So in the first year, there's $1,000. At the end of the year, they give you a payment of 6%. We multiply by 1.06 so that we keep 1 times the original value. That keeps our original amount. And then we add the 0.06. That's the interest payment of, in this case, $60. Now the next year, there's interest earned on top of that interest. So we multiply 1.06 times the 1060, or just take 1.06 squared times 1,000. And you can see the amount grows, and finally, in the year 5, there's $1,262.48. The difference between consecutive terms is called the common ratio. The common ratio in this example is 1.06. Write an equation for T sub n, the amount of money in the bank on the nth day. Again, we have a recursive formula that will start with the original amount, then T sub n, any value out there, will look at the previous value times the common ratio, 1.06, and we have a constraint that n has to be greater than or equal to 2. And for our explicit formula, we're going to use T sub n equals the original value times 1.06 raised to the n minus 1. We want n minus 1 changes to give us our nth value. And again, the same constraint. Are these functions discrete or continuous? They're discrete because the values are generated by separate and distinct periods. There are no partial birthdays or partial interest payments. And we do generalize to continuous functions, and that's a big part of what calculus is about. But in this chapter, we really focus on some discrete values. To generalize then, let's look at recursive and explicit formulas for both arithmetic and geometric sequences. For arithmetic, the recursive formula looks at T sub 1 being the first term, and then any value out there, some nth value, looks at the previous and adds D, which we call our common difference. If we want to look at the explicit formula for arithmetic, we can find any value T sub n by taking whatever the first term is, T sub 1, and adding n minus 1 differences, or D times n minus 1. For geometric, same idea, first term, and instead of adding a difference, we multiply by a common ratio. And then to generalize for our explicit formula, we take our starting value and multiply by n minus 1 common ratio. All right, now let's practice. Are these arithmetic, geometric, or neither? Well, for this first sequence, what we would do is try subtracting. I always subtract on the top, divide on the bottom, just for consistency. I look at the top here, it changes right away. I don't have a constant when I subtract. So if I do division, I end up with a 0.75. If we look over here at 7, 9, 13, and so on, if we try looking at the difference, we get a varying difference, so it's not constant. We wouldn't say it's arithmetic. And then if we look down here, nope, we don't have a common ratio either, so this one is neither of them. Negative 4, 7, 18, 29, do some math, we get a constant of 11. Okay, I've got a couple of problems here that I'd like you to read through, try on your own. The answers will be given, and then there's an on your own, and we'll meet in class. So, find the following for the sequence. 64, 48, looks kind of familiar. Go ahead and try this, hit pause, and then start up and see how it goes. All right, as we had discovered earlier, this one is geometric. It's got a common ratio. That common ratio is 0.75. To find the sixth term, we want to do 5 differences of times 0.75, and we get a value as shown. And then to write the formula, you're going to start with your initial value of 64. You're going to take the previous times 0.75 starting at 2. And then likewise, the explicit starting value times the ratio raised to the n minus 1. Remember on your calculators, if you raise to the n minus 1, you should put that in parentheses because your calculator will do exponents first. It'll raise to the n and then subtract 1 if you're not careful. Okay, find the following for the sequence. Go ahead and hit pause. All right, this sequence we saw before, it's arithmetic. What's the common difference or ratio? In this case, it is a common difference. And that common difference is plus 11, or positive 11. To find the sixth term, we take the starting value and do 5 changes to it, in this case plus 11, 5 different times. And then our recursive formula starts with negative 4, looks at the previous and adds 11 to get the next. And for explicit, we would simply take the starting value and add n minus 1 changes to get the nth term. All right, go ahead and try this on your own, and we'll meet in class.